Welcome to Brain Vision.
So question suggests this is a 0.15 mole per liter morphine solution, which has a pK of 10.5. So we know the pH of the solution is 10.5. Then the pOH of the solution equals to 14 minus pH, which is 3.5. We also know pOH is the negative log of the hydroxide concentration at equilibrium stage, which we can calculate the concentration of hydroxide at equilibrium stage is 10 to the power of negative 3.5. Okay. Now, question suggests that morphine is a weak base, so we will use B here to represent morphine. So there are two major species in the solution. One is the base, the other one is water. Even they're all bases, water would not be considered as a source of hydroxide. So now we can write out the dominant equilibrium. So base at the presence of water would dissociate into Hb plus, the protonated base, and hydroxide. We should be able to write an ice table. So initially, the concentration of base is 0.15. Because water is the solvent, so we do not consider the concentration of water. There's no protonated base and also no hydroxide existing in the solution initially. Then we know that at equilibrium stage, there are 10 to the power of negative 3.5 concentration of hydroxide existing. So it will be the same amount of change for the protonated base form. We also not going to consider the concentration of water. So in this case, at equilibrium stage, we see the increase in both protonated base and hydroxide. In the other side of this equation, then the concentration of base would decrease. So at equilibrium stage, the concentration of the base would be 0.15 minus 10 to the power of negative 3.5. So once we obtain the concentration of each major species in the solution, we would be able to calculate the Kb from the concentration of the protonated base at equilibrium state times the concentration of the hydroxide at the equilibrium stage divided by the concentration of the base, which we can plug in all three numbers here. Negative 3.5 over 2 divided by 0.15 minus 10 to the negative 3.5. And the result of this calculation will be 6.66 times 10 to the negative 7 as the value of Kb.